This video is to review the materials covered up until Test 1. On Test 1, we'll have an application test, which covers this study guide. We will also have a fluency test. During the fluency test, the students will be expected to complete without a calculator the skills that we have worked through this school year so far, including turning numbers from scientific notation to standard notation, from standard notation to scientific notation, simplifying radical expressions, converting repeating decimals and terminating decimals to fractions, and from fractions back to their decimal form, as well as classifying numbers according to their number sets. On this study guide, we start with number 1, which is actually a converting repeating decimals problem. We want to know which fraction is equivalent to 0.36 repeating, and we're going to write our answer in simplest form. The digits that repeat here are 3 and 6, and that is our entire repeating pattern, so we're able to take 3 and 6, place it over 2 9 since 2 digits repeat, and then reduce. Both of these numbers are divisible by 9, which leaves us with 4 elevenths, and that is our simplified answer. In number 2, when we're simplifying the radical expression, we're trying to figure out what two whole numbers that are consecutive the square root of 30 would fall between, which means we have to know our perfect squares. 1 squared is 1, so we would be taking the square root of 1, and 3 squared is 9, so we would be taking the square root of 9. 30 does not fall between 1 and 9. 4 squared is 16, and 5 squared is 25. 30 does not fall between 16 and 25. 5 squared is 25, and 6 squared is 36. 30 does fall between 25 and 36. Therefore, the square root of 30 will fall between 5 and 6. As we go through number 3, we should start by simplifying the exponential expression here. And we start by doing that by using the product rule, in which we multiply the exponents. So that's going to leave us with negative 2 to the 2 times 3, or 6th power, and our base is negative. And we'll be adding that to 3 squared to the squared power, or to the second power, which is going to give us 3 to the 4th power, because multiplying the exponents will give us a 4. Now, when we figure out negative 2 to the 6th power, we identify that that is equal to 64, and 3 to the 4th power is equal to 81. So now when you add those together, you get 145. So we should be checking, if we're going to mark all that apply, to see which of these will simplify down to 145 as well. Again, we're using the product power, or the product rule for exponents. Therefore, we're going to multiply the exponents, which gives us 2 to the 6th power plus 3 to the 4th power. And you're multiplying that 2 an even amount of times, so it doesn't matter whether the 2 is negative or positive. 2 to the 6th power is going to give us that 64, and 3 to the 4th power is going to give us that 81, which when added together will give us 145. For B, you'll have 2 squared and then squared, so that's going to be 2 to the 4th power. You'll multiply that by 4 and then add it to 3 to the 4th power. 2 to the 4th power is 16. 16 times 4 is 64, and again we get that 64 plus 81, which is going to give us our 145. For C, we have 2 cubed raised to the 2nd power, which is going to give us 2 to the 6th power. And we're going to add that to 3 to the 4th power, which we know is going to give us that 81, and 2 to the 6th power will give us that 64. So when we add them, we will get our 145. For D, we have 3 to the 4th power plus 3 to the 4th power, which is going to give us 81 plus 81, which is going to be 162, which is not 145. For E, we again will have negative 2 to the 6th power. And 9 squared is 81. We know that negative 2 to the 6th power will give us our 64. And 64 plus 81 will give us our 145. For F, negative 2 cubed to the 2nd power is going to give us negative 2 to the 6th power overall. And we are adding it to 3 to the 4th power, which we know will give us our 64 and our 81. So that again will equal our 145. In number 4, it says which statements are true. Mark all that apply. We're asking about cubing the y value and what the result will be. And we give you a variety of different y's. So we're trying to see which ones are true. Starting out with A, we know if we cube 3, that is 3 times 3 times 3, which will give us 27. So y cubed here equals 27 is a true statement. In B, you're going to cube your 4, which is going to be 4 times 4 times 4, which will give us 64. So here y cubed equals 64 is a true statement. For C, we are cubing 1, and 1 times 1 times 1 will in fact give us 1, so y cubed equals 1 is a true statement. For D, if we were to cube 2, we would come up with 8, because 2 times 2 is 4, and 4 times 2 is 8. So y cubed equals 16 is a false statement. In number 5, we are converting 0.7 repeating to a fraction and simplifying if possible. 7 is the only digit that repeats, and it's only one number. So we take our 7 and place it over 9, and 7/9 does not reduce any farther. In number 6, we are converting 0.8 repeating to a fraction and simplifying if possible. Again, that 8 repeats. It's the only thing that repeats. It's only one digit that repeats. So 8 is placed over 1/9, and 8/9 does not reduce. In number 7, we're asked to turn 0.9 repeating to a fraction and simplify. Again, 9 is the repeating pattern. It's the only portion of the repeating pattern. There's only one digit that repeats, so you take that 9 and place it over 1/9. But in this case, 9 over 9 will reduce. It will reduce to 1. So we notice in number 8, part D, it says, does your answer to part C make sense? And explain your reasoning. It does not make sense, because when converting numbers between fractions and decimals, you should be able to go back and forth between the two. So because you should be able to, divide the numerator, which is 9, by the denominator, to get the decimal. Which is 0.9 repeating. But we don't get 0.9 repeating. Instead, we get 1. In number 9, you're asked to consider the equations x squared equals 25 and y cubed equals 8. We want to know how many solutions does each equation have and fill out the blanks in the statements. So when we're looking at x squared equals 25, we're wanting to know what value squared will give us 25. And we know that when we're squaring something, we're multiplying it together by itself 2 times. And 5 times 5 will give us 25. But also, multiplying negative 5 by negative 5 will give us a positive 25 as well. So that means that we have two solutions. For y cubed equals 8, we want to know what multiplied by itself an odd number of times, or 3 times, will give us 8. And we know that 2 times 2 times 2 will give us 8. But we have to consider negative 2. And negative 2 multiplied by itself an odd number of times, negative 2 times negative 2 times negative 2, that's going to give us negative 8. So there is only one solution here. In number 10, it actually asks us for the solutions, which x squared equals 25. We know that 5 squared will give us positive 25, and negative 5 squared will give us positive 25. For y cubed, we said that positive 2 times positive 2 times positive 2 will give us that positive 8, but a negative 2 will not. It will give us a negative 8. So in part C, we wanted to kind of explore it using the calculator, asking that why it's possible that the square root function will only give you one solution when you should have two, whereas the cube root function will give you the one solution that is correct. And the answer that we mentioned in class dealt with the integer rules. And we said when taking a square root, you are finding what is multiplied by itself an even amount of times, which according to integer rules could be a positive number or a negative number. However, a cube root is finding a number that is multiplied by itself an odd amount of times, meaning the result must either be a positive or a negative, but can't be both. So when using the calculator here, you have to understand the integer rules and not only rely on the calculator. Number 12 relates back to our number sets when we ask which numbers are irrational and mark all that apply. We know that natural numbers are numbers that are 1 to infinity, and they must be whole numbers. Whole numbers go from 0 to infinity, and again, they cannot be parts of numbers. Integers are numbers that are negative infinity to positive infinity. They also cannot include parts of numbers like decimals and fractions. Once we get into the rational category, everything we've already mentioned, natural, whole, and integers, are all rational, but rational numbers are numbers that can be written as a fraction. They can also be written as a terminating decimal or a repeating decimal. Irrational numbers cannot be turned into a fraction of two integers. They, for example, are non-terminating decimals, decimals that continue on forever with no pattern. They are also pi and non-perfect squares. Real numbers are any number that can be put on a number line, and all natural, whole, integer, rational, and irrational numbers are considered real. So when we're looking at these options, we can go ahead and classify them according to their number sets. A is a fraction, which we know is rational. It's also real. Negative 4 is not natural or whole because it's negative, but it is an integer, which makes it rational and real. For C, we have a repeating decimal, which is a rational number because it can be turned into a fraction, and it is real. The square root of 11 is a non-perfect square, which means it's going to give you a non-terminating decimal or irrational number. It is also real. Pi is a perfect example of irrational numbers. It's a decimal that keeps on going. So it is irrational. It is also real. And F, again, we have a fraction, so it's not natural, whole, or an integer, but because it's a fraction of two integers, it is rational and it is real. So we've identified two numbers as irrational. That is D and that is E. For number 13, we need to simplify the expression to figure out what is equivalent. And we look at the numerator first and identify the product rule. In the product rule, you add the exponents. So we have 2 to the 6 plus negative 4, and 6 plus negative 4 is 2, and that is over 2 to the 7th. According to the quotient rule, we would subtract the exponents. And when you say 2 minus 7, that leaves you with 2 to the negative 5th power. You can't be left with a negative exponent, so you give it a reciprocal, meaning you've placed it over 1, and you drop the 2 to the negative 5 to the denominator, and it now becomes 1 over positive 2 to the 5th power. And 2 to the 5th power is 1 over 32. So now that we have a progression of simplification, we can look and see what answers are matched in our choices. We started out with 2 to the 2nd over 2 to the 7th, and that is the same thing as E. F would not be correct because that says 2 to the 3rd over 2 to the 7th. Once we get to 1 over 2 to the 5th, we can take a look at our fractions, which include the expanded power rule, where we give our 4 to the numerator and the denominator, and we give our 5 to the numerator and the denominator. We know 1 to any power is always going to be 1, so this is 1 over 2 to the 4th power, and 1 over 2 to the 5th power. The one that matches what we're looking for is D. And when we simplified that, we came up with 1 over 32. If it's 1 over 32, it cannot be 1 over 16. In 14, we want to know which is true. And we're making a comparison with the square root of 21. We know that the square root of 21 is going to fall between the whole numbers 4 and 5, because 4 came from the square root of 16, and 5 came from the square root of 25, and 21 is between 16 and 25. So we know that 4 will be less than the square root of 21, and the square root of 21 will be less than 5. If we wanted to find out its comparison with 4.5, we can square 4.5 to see how close it is to 21. So 4.5 squared is 20.25, and 21 is greater than 20.25, so it's not going to be less than. But C says that the square root of 25 is greater than 4.5 and less than 5, so that's a true statement. Indeed, they made the mistake of just dividing the 20 by 2 to get numbers to be between. It's not going to be between 10 and 11 because 10 squared is 100 and 11 squared is 121. So it also can't be between 10 and 10.5 or between 10.5 and 11. In 15, which expressions are equivalent to 1 over 16, and mark all that apply. In all of our options, we're looking at the product rule for laws of exponents, so we'll be adding together the exponents. Negative 9 plus 7 is negative 2. 9 plus negative 7 is positive 2. 10 plus negative 12 is negative 2. And 5 plus negative 7 is negative 2. So essentially, if we look at A, what we have is 4 to the negative 2nd power. In order to make that a positive exponent, we would use the reciprocal, making it 1 over 4 squared, which is in fact 1 over 16. So all of our exponents of negative 2 are going to give us that result of 1 over 16. In number 16, we want to know what decimal is equivalent to 21 over 99. You can do 21 divided by 99, or you could recognize that 2 nines tells you that 2 digits will repeat, which means that we will have the repeating pattern 21, 21, 21, which is told to us in B. In 17, we want to know which statements are true and mark all that apply. The values of the square root of 30 and the square root of 37 are between 5 and 6. Well, that would be comparing the square root of 25 and the square root of 36. And since 37 is bigger than 36, these are not both between 5 and 6. For B, the value of the square root of 13 is greater than the value of the square root of 17. The square root of 13 falls between the two whole numbers, 3 and 4. And the square root of 17 falls between the whole numbers 4 and 5. So a number that is between 3 and 4 cannot be greater than a number that falls between 4 and 5. In C, the value of the square root of 21 is between 4 and 5. So 4 and 5 would be between the square root of 16 and the square root of 25. And that is an accurate statement. And the value of the square root of 53 is between 7 and 8. Well, 7 and 8 is between the square root of 49 and the square root of 64. And 53 does fall between 49 and 64, so that's a true statement. Indeed, the square root of 39 is between 5 and 6. 5 and 6 would be the square root of 25 and the square root of 36. And 39 does not fall between 25 and 36, so we can already eliminate this statement. The values of the square root of 19 and the square root of 23 are between 4 and 5. Well, that would be between the square root of 16 and the square root of 25. 19 and 23 both fall between 16 and 25, so that is a true statement. And the value of the square root of 73 is greater than the value of the square root of 67. These both fall between 8 and 9, which that would be the square root of 64 and the square root of 81. 67 is going to be closer to 64 because there's only a difference of 3 there. And the square root of 73 is going to be closer to the square root of 81. So it's an accurate statement that the square root of 73 is going to be closer or greater than the square root of 67. In 18 and 19, we are turning standard notation into scientific notation by turning the Earth's population and Canada's population into a number that is greater than or equal to 1 but less than 10 times a power of 10. And both numbers are decimal, is currently at the end. So we need to move that decimal to where we can drop off the zeros and leave only the whole numbers that we could get back to originally. So that means that we want our decimal for Earth's population to be 7.09. That's a number greater than or equal to 1 and less than 10. And we'll multiply that by 10 to some power. And the power is determined based on the amount of times we move the decimal. 1, 2, 3, 4, 5, 6, 7, 8. 9 times the decimal was moved. And so this statement is telling you that to get back to your original population, you would move your decimal 9 places back to the right. For Canada, our number that is greater than or equal to 1 but less than 10 would be 3.5. We would multiply it by 10 to a power, and the power is determined by moving the decimal to be between the 3 and the 5. And to make that happen, we had to move our decimal 7 places to the left, which means to get back to our original, we would have to move 7 places to the right, which is what our scientific notation is telling us. For number 20, you're asked approximately how many times as great as the population of Canada is the population of Earth. And when you are asked how many times as great, you are asking, what did I multiply by? And in order to figure that out, you have to divide. So the statement is telling us that Canada times some amount will give us the Earth's